Hi, so we've got a PS5 where the customer tried to repair the HDMI port themselves, and it's messed up pretty badly. If you take a look at the port under the microscope, it's got a bunch of solder all over the place, and it looks like they've ripped up some traces as well. It's not in good shape. Now, when you get a device like this, one of the first things we like to do is make sure it boots on still. So we'll plug it in, and if the light on the PS5 goes steady white, it means it's booted on fully. And in order to make sure it's not freezing or something stupid like that, once it's on, press and hold the power button to turn it off. It'll beep twice and then shut off. So if it shuts off properly, then you know that the PS5 is booting on and not freezing. Let's confirm that it boots on, and then I'll disassemble it. Excellent. So the PS5 powers on fully. Let's disassemble it and we'll take a look. At first glance, this looks pretty bad. We have a lot of work ahead of us. First step is let's clean up all the bits of old solder hanging about, and then we'll tin the board with fresh solder, and then we'll use a desoldering braid to clear up all of the old solder from the holes. Once we're done that, it's time to clean. This board looks like a big mess. So once we use some isopropyl alcohol and a microfiber cloth, it starts looking a lot better, much more manageable. Next step is to clean the PCB mask put on the board. Not only is this PCB mask very clumpy, which prevents the HDMI port from sitting flush with the board, but it's also covering the points, also called vias, the ripped HDMI pads are connected to. In order to repair the PS5, we'll have to painstakingly rebuild all of these connections. Though it may seem counterintuitive that I'm applying PCB mask after having just cleaned the old stuff, there's a bit too much copper exposed around the HDMI port. All of this exposed copper will have to be masked to prevent problems such as short circuits when we go to install the new port. After curing the PCB mask with a UV lamp, we can now go about rebuilding the broken traces. The first step in this process is to apply some fresh solder to the tiny nubs that are left on the board, and then I check it with a multimeter and confirm that they do not have a short circuit. Next, it may look like I'm putting the port back on the board too soon, but there is a method to this madness. Because the pins on the back of the HDMI port are so tiny, I prefer to install the port first and then run jumper wires from the back of the port to their corresponding traces on the motherboard. Sure, we have no cold solder joints under the HDMI port. I use hot air along with my soldering iron to fully liquefy the solder and make sure it has bonded with the anchors on the motherboard. Next, I use a soldering iron and apply a generous amount of solder to the pins on the HDMI port. This will come in handy later when we are rebuilding the traces. To reconnect the pins on the HDMI port with their corresponding vias, I use a jumper wire that is 0.02 millimeters in diameter. This is quite literally thinner than a human hair. You best not have a shaky hand when doing this kind of work. Since I've already applied solder to the vias and the pins on the port, all we have to do now is to hold this thin jumper wire with tweezers and then attach one end to the pin and the other end to its corresponding trace, and then cut the jumper wire without damaging the via it's connected to. This is easier said than done, but I hope I'm making this look easy. After connecting all of the data lines to the port, I measure them with a multimeter. This serves a dual purpose. The act of poking the pin with the multimeter confirms that the jumper wire is solidly attached, and the multimeter reading also confirms that the line is healthy. You shall soon see why this is so important. The 5-volt power rail that provides the HDMI port with power has a partial short circuit that will have to be fixed. Turns out we have a partial short on here. Now, when I checked the board view, we don't have one for the EDM040 board, but we've got one for the EDM10. And thankfully, the they all go to the same place. So this line goes over here, and it is still partial short. Now, these boards largely have the same layout, and I don't think we're supposed to have a resistor here. And the resistance of this resistor is reading at 100 ohms. Now, I'm genuinely not certain if this resistor is correct. It looks like it's been soldered on there, so I wonder if whoever worked on this board lost that component and then just replaced it with a random one, because that's what that looks like to me. We're going to take that resistor off and we'll see if that reading changes. And then if it does, I'll put a diode on there, which is what it is supposed to be, and we'll see if it makes a difference. So right now, I'm not sure if this resistor is supposed to go on there or not. So what I'm going to do is I'm just going to shunt it to the side, and then we'll take a reading. And then if that reading checks out, then we'll replace that component from a donor. Come on. Okay, should be like that. There we go. Now, the board is still hot, but the reading should have changed. Oh, resistance. Let's go to diode mode. And that looks a lot more like it. Okay, let us swap that part out with the diode and we'll see if something changes. So in diode mode, that's the line now after the resistor's been removed. And this is the line we were checking. And if you look at our Huntron tracker, the signature has now improved and it matches a known working motherboard. Excellent. Oh, let me actually show it to you on the HDMI port, because that's where this whole thing started. So now that line is good. And if we check it in diode mode, 0.380. Excellent. Excellent. After fixing the partial short circuit, the next step is to mask the rebuilt traces to secure them to the motherboard. This is done first before we attach the ground pins to the board to ensure that the traces we've already repaired are not accidentally disturbed when we go to solder the ground pins to the board. Still have to connect the ground pins, because the way I decided it is, if you look, I'll show you once we're done curing the mask, but there are two data lines and the ground is in between them. Mm-hmm. So it's like the two sets, one pin is ground in between, then again two sets. So there are two data lines that are always adjacent to each other. So, and the way they've designed those vias for the ground in between those data lines, like those vias aren't in front of the ground pins.
No, and usually on the port, what they do is they have the data lines going out the back of the port, and they pull the ground out the front and connect it to the copper at the edge of the board.
Mm-hmm. So what I'm thinking here is I'll just run a jumper straight from the pin to the inside edge of the board and connect it to ground there.
Works fine. I've done that before.
Yeah, I feel like that's a simpler way to do this than to try and run ground pins underneath the port.
Yeah, we're well over a minute and a half.
Oh, perfect. Thank you. Now let us take a peek. Should look gorgeous. Excellent. Look at that. On an undamaged PS5, the ground pins are attached to the board on the underside of the HDMI port. Since that area of the board is not accessible with the port installed, I have to scrape the ground plane on the motherboard behind the HDMI port to be able to reconnect the ground pins. We also have a missing capacitor on the back of the HDMI port. This is a 0.1 microfarad capacitor that I can harvest from an iPhone 6s motherboard and install it on the PS5. With the traces reattached, the next step is to clean the board. I cannot stress how important this is. If left dirty, besides looking gross, the components are more likely to oxidize or build up a layer of dust over time. And speaking of cleaning, we have a whole lot of that ahead of us. I am legitimately amazed that this board did not have catastrophic damage. PS5s use liquid metal as a cooling substrate between the surface of the APU and its heatsink. And this metal is electrically conductive, so it is extremely important that you're very careful when working on the PS5 motherboard. If this liquid metal gets on the board, it could cause short circuits and could potentially kill the board if a high voltage line is short-circuited to, let's say, the APU or the SSD. The surprising part is that this device had liquid metal all over the board, including the SSD circuit. So it is extremely lucky that it didn't have any catastrophic short circuits. Because the liquid metal is, liquid, it can be quite sneaky. So even though it feels like it takes me forever and a day to clean the board, this is one of those things where it pays to be thorough. Especially after putting all of this work into rebuilding the HDMI port traces, it would really suck if the device died because of a blob of liquid metal. After cleaning the board of liquid metal, I apply a final layer of PCB mask behind the HDMI port to secure the traces to the board properly. After that is done, I poke all of them with my tool to make sure that they are all secure and solidly attached to the pins on the HDMI port. Doing this ensures that the traces remain solidly attached and will stand up to normal use when the HDMI port is plugged and unplugged from the device. After checking the pins for structural integrity, the next step is to measure all the pins on the back of the port with a multimeter and confirm that they have a healthy reading in diode mode. This final test verifies that the trace repair is structurally and electrically good, and the device is now ready for the moment of truth. Let's pop the motherboard back in its housing, and we'll power it on and confirm if it has image.
No. Okay.
Thanks so much. Excellent.
All right, the PS5 is in its housing. Let's see if it will work.
Yes, it is fixed.
Awesome. The trace repair on the PS5 HDMI port was a success. Excellent. HDMI ports are just the beginning. If your PS5 has a deeper motherboard issue, don't trust it to a generalist, send it to a specialist who handles component-level repairs every day. Head to repairtechrx.ca to start your mail-in repair and get back in the game.